Okay, so a few weeks ago, I visited this existing pumping water scheme. But the issue is there are some few important data that we could not manage to get on site. The data like pumping discharge and also pumping head, they were not there. So the issue is how to estimate them. Of course, we managed to estimate the pumping discharge, but the other problem was to find pumping head. So this was the pump. So this was the project. Of course, the place where the project is located, and this is where our pump is. Of course, it's not a groundwater pump. It is a pump located somewhere in the sump, installed in the sump, and also this one here is our storage tank. So this is our raising main. As you can see, this is our raising main. This is our sump where our pump is installed, and this is our storage tank. So as I said earlier, we found a way to estimate pump discharge, of course by using the following information. So the existing sump here, so here our pump is installed within this sump. Okay, so this is the sump. As you can see, it is 145 cubic meters sump, and also it takes 6.5 hours for a pump to empty this sump. Okay, this is very important information. Not just that, so if you take that information, you can see that the estimated discharge for this pump is around 6.2 liters per second. Okay, as I said, the raising main here is 4 inches. So this raising main here is 4 inches. The raising main here is 4 inches, and not just 4 inches, but it is also a steel pipe. Okay, a steel pipe. So this is the sketch, a simple sketch for our project. This is our sump, and this is pump installed within this sump, and again this is our tank. Our sump is located at this elevation, which is 1634, and also our tank is located at this elevation, which is 1845. So our pump is pumping water from this sump all the way to this tank, all the way to this tank here, which is this one here. Okay, and the other information here is that our tank, so the initial water level for this tank here is 3 meters, and also the minimum water level for this sump is 1 meter. Okay, so below this depth the pump is not operating. And also the total height of this sump is 3 meters, and of course the rising main pipe here is 4 inches steel pipe. So this is the information that we have. So I asked myself, even though we managed to get the Q, what if we use software like EPANET, okay, EPANET, to estimate the pumping head? Today we are going to use EPANET, but in the future I will also cover the same problem by using WaterGEMS. So this is the problem that we want to cover today. If you are new here, my name is Engineer Lodrick, and this is Hydroinformatics Academy. So if you want to support my channel, I created a Patreon link, and I'll make sure that I include it in the description below. So with that out of the way, let's get started. Okay, so before we proceed, if you want to learn how to extract data from Google Earth, this is the tutorials that I will advise you to go and watch. Okay, so I'll make sure that I include the link to these two tutorials in the description below. And again, if you want to learn how to import data or survey data in EPANET, again, this is the playlist that I will advise you to go and watch. For me, I have already inserted my data in EPANET, of course 2.2, and this is my network. This is the storage tank, and again this is where our sump is. So we need to model this network and to see if the design is okay, and also to find the estimate for a pumping head. Okay, so before we even move further, there are a few things here that we need to cross check. The first one is at this point here, the elevation for now, elevation value that we are having is this ground elevation. But if I take you back here, you can see, so at this simple sketch, you can see that the ground elevation here is this one, which is a 1634. But remember, this is the minimum water level, and the total static head, okay, the total static head is from this point here all the way to this point around here. So this is our total static head. The elevation value that we are going to use is not this one, so we need to take this one and then we plus this value here, which is 1, okay, which is 1. So we take this 1634 plus 1. The value that we are going to get here is 1635, and again at our storage tank here, this is the ground elevation. But if we go back here, you can see that this is the ground elevation. But remember, our total static head is from this point here all the way to this point. So at our storage tank, the total elevation is going to be this ground elevation plus this 3. Okay, remember, is from this area to this area, so this ground elevation plus 3, which is 1848. That is the value that we are going to adapt at this elevation here. Okay, so the other values are just maintained the way it is. Of course, the initial level is 3. Okay, so at least for now, so far so good. And if I check the other values, I don't think if there is anything that I can change. The pipe length, okay, is okay. We need also to make some few changes here. Let me go back here to project and make sure that my units are okay. So for flow units, I want to use liters per second, and the head loss formula, I want to use the DAS Westpac. Okay, not Hazen William, but DAS Westpac. And again, I'm going to click OK because there is nothing here I can change. I just click OK. Now, to model water pump in EPANET, what we need to do, of course, we have two options. So the first one is by using a negative value or the negative demand, and the other approach is by using the combination of reservoir and the pump. Okay, so for this tutorial, we are going to use the combination of reservoir and the pump. But if you want to learn how to model a water pump by using negative demand, I have this short tutorial. So if you want to learn, you can go and watch. Of course, I'll make sure that I put the link to all of these tutorials in the description below. Now, because we are going to use a combination of reservoir and pump, let me start by taking this reservoir here. Grab this reservoir, put it here, and again take this pump and click at our reservoir and take it to this point. Okay, the elevation at the reservoir here, so we need to copy this elevation value, which is 1635, and you use the same value at our reservoir. So this here elevation here is 1635. Okay, now one thing here that we need to add is the pump curve. For now, we don't have any pump curve. What we can do is to create one. So from here, let me select curves and of course click add. Okay, so add data, select curve, then click add curve. You can give it a name. For me, I'm going to give it pump 1. Not just that, because the discharge that we want to use is this value, which is 6.2. This is the value that we want to use, 6.2 liters per second. So we want to model our pump in such a way it deliver, or it's supplied from the sump to the storage tank 6.2 liters per second. So here I'm going to insert 6.2, which is of course in liters per second. Now here is the trick. We need to insert head. Okay, so at this column we have flow, but here we have head. For now, we don't know the value of head. Now, with this approach, we are going to perform several iterations, and the best iteration is the iteration where our pump is going to supply 6.2 liters per second. For now, let me cancel this. Just a moment. Now, the initial value of head So there are several approaches you can get the initial value of head, but what we can do is to use this simple trick. Okay, I'll just click this destination point, which is a storage tank. We can take this elevation here, which is 1848 minus this one. Okay, so what we are doing is a very simple trick, is because, as I said earlier, our static head will start from this point here to this point. So at this point, the elevation here is 1848, and at this point here, the elevation is 1635. So if I take this value and minus 1635, what we are going to get is a static head. Okay, simple as static head. So this is going to be our first head iteration. So let me go back here, select curves, select this one. Of course, let me give it the same name. Remember, the flow here was 6.2 and head. So the first iteration for head, we are going to take 1635 minus 1848. Okay, so the value that we are going to get here is 235. So let's use this as our first guess value, or the guess value for head, and let me click OK. Remember, what we are aiming to achieve here is the head that is going to deliver 6.2, which is the flow that we want to supply to our storage tank. Now, with that out of the way, let me click run. Okay, it seems as though we have some issues. Okay, so let me take this value, the curve, and copy this curve ID and insert it at our pump. This is something that I forgot. Let me paste it and run. So for now, we don't have any error, but what I want to do is to display the link and the junction values. Let me right click and click options. Now from here, let me select notation. I want to display the link value and node value. Okay, and let me go back here to browser, select map, and again at map, let me select, so at each node I want to display the pressure. Okay, so this is our pressure, and at each link for now, because what we are aiming is to achieve that 6.2 as a flow. So let me display here the flow. So you can see now we are having some issues because our models tell us that our pump is supplying only 0.02 liters per second. So let me click any link. As you can see here, the diameter here, the pump diameter here is quite small, which is the default value. And again, the roughness here, what we are using here is the Hazen-Williams, which is not correct. Now let me start with the roughness. If I grab this PDF, you can see for steel pipes, this is the K value, which is of course in millimeter. So if I take this, the average value here is going to be 0.09, if I'm not mistaken. So this is the value that I'm going to adapt, because our pipes are steel pipes. That is the value that I'm going to adapt at our model. Let me click this and insert here 0.09. So, and also this 0.09, but this is going to take a lot of time. Let me use this tool, which is a region. Select from this area to this area, again this area. We want to, so let me click edit and select group edit. So for all pipes, I want to change the roughness to, okay, for all pipes I want to replace roughness with 0.09. You can see now this is the value that I have for each pipe. Again, the other value that we want to change is the pipe diameter. Of course, we have steel pipe, but as I said earlier, the value, the rise main pipe is 4 inches pipe. Remember, we want to use the inside diameter or the internal diameter ID, pipe ID. Now with that, so the internal diameter for 4-inch pipe is 96.8. So I'm going to adapt that value, which is 96.8. But again, we want to use this region tool and select this region, then right click to close this loop. Then from here, what we want to do is to select group edit, and again for all pipes I want to replace the pipe diameter with 96.8. Remember, this is the 4-inch pipe and this is its internal diameter. Let me select OK. Let me run again and see what we're having. Again, the value here, they are quite small. Let me increase a little bit. So the font size is 10. Okay, so from here we can see that at this head, okay, so let me go back here and select the curve. So at this head here, which is this value, we can see our pump is delivering only 4.8. So in a simple word, at this head our pump is delivering 4.8 instead of 6.8. So we need to increase a little bit head. We need to increase a little bit the value of head. Now let me take it from 213 to let's say 30 and see what we have and see what we're having. Let me run again and see if remember, at each link we are displaying flow and see. So let me run my model and see if the flow here changes. Let me run. You can see now our value or our flow value has changed from 4 to 5. So we need to change the value again. So at this curve, let me increase a little bit value to let's say 250 and see what we are having. Remember, what we are aiming to achieve is this flow here, which is 6.2. Let me run again and see if we have any promising value. You can see now we are almost close. For now we are having 6.09, which is not the value that we want, because what we want is 6.2. Let me increase a little bit, let's say 260. So now we are having 6.3. that is quite big, a little bit big. So let me reduce a little bit to 255. So at least now it is not bad, because according to our model, at this head here, our pump is going to deliver 6.22. Not bad. Okay, not bad. So far we have managed to get the pumping head. So for this pump, we can say, okay, so at this flow, which is 6.2, the total pumping head is not below 255. Okay, but let me check other parameters like velocity and unit head loss and see what we are having. So for velocity, let me check velocity. Let me go back here to links, change from flow to velocity. You can see the velocity value is 0.84 meters per second. Again, it is not that bad because it is within the acceptable range. Depends from country to country, but for the most cases, velocities should not go beyond 1.5 meters per second. And again, let me check for links. Okay, let me take it from map, and let me check links. Let me check unit head losses. So for unit head losses, what we are having now is at least 8.49. Again, this is not bad because the recommended value is having a unit head losses value which is not beyond 10 meters. But for now, what we are having here is 8.49. Because we have checked the velocities and unit head losses and also the flow, what we can do from here is to prepare a simple report for our model. Of course, we can go here, report, and select full, of course, a report, then select full. From here, of course, save with the same name, test2. Okay, so this is the flow, which is 6.22, and again, this is the unit head losses, which is 8. 0.49, and again the velocity, which is 0.94. And lastly, this is our pumping head, which is 254.57. So far so good. We managed to use EPANET to estimate the total pumping head for our existing water pump. So with that, thank you. And again, I created a Patreon link, so if you want to support my channel, link will be in the description below. Thank you, and I will see you in the next video.